intelligence. So, I mean, to me, when I approach AI, the mind, intelligence, it's kind of based upon understanding, reasoning, and judging. And understanding we covered a couple of years ago, I thought that in a pretty good uh, event. And reasoning we haven't done yet. Judging, there's already been two prior events. But what I've been having a hard, it's hard for me to get my mind wrapped around this, and I don't have the answers. This is kind of like a good Sunday philosophical exploration rather than, I'm going to present some kind of answers kind of a thing. But just as by way of a kind of introduction, um, I think of a judgment as it could be something else. So that's the main consideration. So if it's a really simple situation and the decision is kind of a given, then that's not really the concern right now. That's important, but it's not the concern right now. It's if a machine can come up with a different judgment than the one that it has. And so in undertaking that, hopefully within the context of this event, we can try to characterize the problem some more and look at some possible solution designs having done that. So just as a quick review of the first event, which was now a couple of years ago, what I did was I read a large compilation of basically essays, studies, papers on judgment and decision making. It's called the book is called The Handbook of Judgment and Decision Making, and I've just highlighted some of the points that I thought were the most important to me anyway, that kind of stood out. Mostly, it's that I came away with this feeling that AI, whatever we do, we shouldn't really make it like human judgment. I mean, I guess there's arguments for that, but there's a lot of problems too. Like in general, people are overconfident in their judgments. Heuristics and biases, we all use that. They're fast. I think I'm going to do this. So in the same case, we reapply the same thing a lot. A lot of people get too wrapped up in their own inner deliberations, and not enough attention is paid to the external evidence. So there's some major themes that keep coming through again and again in this, and the upshot is that, I mean, in computer science and statistics, the stuff they teach us in college or wherever, or high school or wherever you want. I mean, basically, it's how to maximize something. You're always looking at how to get to the top of the graph, but the reality is we don't think that way, and maybe we shouldn't. Anyway, that was the first. I'm just reviewing the first event. The second one, the second event, I tried to get my mind around what is it that's bothering me about this, because it seems like a real judgment has kind of a free will aspect to it, and there's definitely an element of intuition, but some of it's conscious reasoning too. And in a lot of different dimensions, there will probably be uncertainty, and people weigh the different uncertainties in different fashions. And it's difficult to tell in a system what's a fact, what is a fact, and what's a judgment. So I want to just try to characterize what I've been kind of feeling about this, what I call a true autonomous AI judgment. True meaning authentic, not just the opposite of false. But so I listed some criteria here. So if there's a scarcity of evidence to look at, impartial, incomplete evidence, that's one thing that would tip you off that the machine is going to make a possibly difficult judgment. If the machine has not been trained specifically on whatever the problem domain is, that would be another criteria. If there's no hard-coded rules, etc., if nobody sat down and programmed for the machine exactly what to do in some situation, then it's probably more of a real judgment. And the immediate and ultimate outcomes could be difficult to foresee. So reinforcement learning might not be effective. And there's probably going to be, if a human would make the same decision, there might be a lot of intuition and biases, at hand. So I want to pause right here and try to see if everybody's kind of on board with the potential difference between a more or less mundane judgment and what I'm trying to classify as a true judgment. Are there any comments? Let's see if I can. There's a quote that I can read maybe that'll get you thinking about this. And there's a movement called decision making under deep uncertainty. It's not new, but I really like this. And it's they say deep uncertainty is characterized by an inability to make well-informed future projections of a system based upon available data and understanding, and inability to reduce this uncertainty by gathering additional information. Common examples include situations where the probabilities of different outcomes are unknown. Previous data is deemed insufficient. So, I mean, you can't really train it on everything in advance. Experts might disagree on the consequences of different.
So,
kind of a further characterization.
Yeah. What comes to mind is like the Bayesian brain hypothesis, like predictive processing, and that according to that, our brain is optimized, or the whole purpose of our brain is to minimize surprise. And when it comes to ML models, it seems that Bayesian, theory and taking weighting evidence based on that is the optimal approach to weighting any evidence. So I don't know. Is that, maybe you can contrast like Bayesian theory to what you're talking about in terms of true judgment?
Well, in Bayesian theory, I think you have to have a prior probability. Usually, you have to have a prior probability established. So you've got to have a that unless it can learn dynamically. The way I understand, and I'm not an expert by a long shot, but for Bayesian theory, I think you're supposed to have like an expert determine what the prior probabilities are, and then those are taken up into the graph, and then it's updated with it dynamically with events as they occur. But Lance, so what if nothing? What if you've got some situation where you don't have a prior probability?
So Jeff Hinton was interviewed fairly recently, and he basically said that LLMs prove that human intelligence comes from a gigantic prior, meaning that we just have, so much training data that everything that we make judgments on is basically what falls within that.
Did he demonstrate such a system?
I don't know. I mean,
yeah, I get what you mean. I get the meaning though, and I've got some comments about that frame of mind coming up too.
Sure.
All right, thanks. Any other comments? Basically, I'm just trying to get everybody's mind wrapped around what what the problem may be. It's kind of hard to know these days because we're with so many great successes. Where do large language models top off? I mean, where do they get confused? Okay, so I guess if there's no more comments, I'll just keep trying to breeze through this. So
I have a
the
quick
agenda.
question on.
Yeah.
I just have a quick question on the judgment policy for AI for the individual versus a group. It seems to me that most of the questions rely around having the AI model trained on a large data set where it doesn't really particularly matter to the particular user as much, and how you weigh the judgment policy depending on a user versus a group, kind of the philosophy.
Yeah, I mean, it's a great issue and problem. I think, I mean, a lot of people are trying to get around that now with graph networks and things like that. So it could be, it can learn dynamically what preferences are, I think.
So I just came back from Salesforce.com's admin conference, and they're really pushing use an LLM that's only living in your data, so your data is private and secure. That's a data privacy thing, but also sort of preconditioning what's important, what the data is, building the LLM or the Copilot, and then having it work on data with tasks and jobs that it knows how to do, so that they're trying to eliminate a lot of the
Yeah.
erroneous judgments or hallucinations, and it feels like it's going to be kind of a hybrid of a very strict human framework that then the LLM is allowed to go play in as a way of trying to increase the odds that its judgments are relevant to what their values are, aligned with their values, and decrease the odds that it just goes completely wacky and does something that would embarrass them, because they're going to be using this for 1 million transactions a month kind of thing, and they need it to scale.
Yeah.
But I also wonder how we teach frames of reference from which to adjudicate values to an AI, because you need a frame of reference from which to judge your frame of reference. And then how do you know that's the right frame of reference? Well, you gotta, and then you end up in an infinite regress, and it's all got to be operationalized for an AI into numbers. When IBM taught Deep Blue to play Jeopardy, they had to figure out what's the odds that our proposed best guess is right. And then they had another independent process saying, what are the odds it's just totally wrong? And they would combine those two scores to decide whether they were confident enough to go forth with an answer. And that was, Jeopardy questions are a lot of really unstructured data, but apparently eventually that made it better than humans pretty quickly.
Yeah.
I have something to add on these. So from what you said, Chris, I think said, all this conversation, I mean, in general, in the general stage, not you specifically, I think it relies on it directs into the point of making an AI agent think as you like. Because if you want that agent to be autonomous, then is an oxymoron, because you're saying, yeah, you can think whatever you like as long as you think like I want to. So that's kind of it doesn't fly.
Right. It doesn't have any kind of freedom of its own judgment. It's
Right.
you're just telling it what to think.
Yeah. So I'll give you a very example that is very I say contemporaneous right now. You know this Gemini AI? It broke through the news because when, for example, someone asks, "Give me a picture or tell me what a Nazi, Second World War Nazi looked like," it came up with all sort of races and etc. So that's exactly what I was talking about. So the frame of reference that you were talking about was injected in this AI, simply pre-selecting the data to analyze, and therefore to find the correlations that were not there in the real life. So essentially, the programmers provided the Gemini with a set of data that was skewed with respect to the reality in which all of us live to, so that the agent was autonomous in coming up with answers, but it was framed already in certain directions. So it was kind of what I said before. It was thought that the agent was taught to think in the way that the programmers wanted, and they achieved this faking, or at least selecting the amount of data they wanted this agent to be trained on. So yeah, that's what I like in this slide. It says true autonomous, because if you leave an agent, intelligent agent, artificial agent to think and then give answers, that would be true autonomous, because it is done hopefully just reading the data from reality with sensors or whatever. But if you prime them, then I don't know how much at that point. Yeah, it's autonomous because it does by itself, but I don't know.
Yeah, good point. Well, why don't I can just try to breeze through the rest of my, thanks, Luca, and
No worries.
I, so I just want to go over some of the traditional, it sounds like most people here already know about these, but so it'll probably be review, but traditional computational methods for decision making, some recent trends that I've discovered, and then we can have another talk. So here they are. I mean, you're trying to make a decision. The emphasis is on the uncertainty. So as most people know, we've got Bayesian networks, Lance already mentioned, Markov models, and Monte Carlo methods. And I think some other people can probably explain Bayesian networks better than me, but the upshot is that you try to determine what the prior probabilities are in advance, and then when things happen, then we update the graph, and the probabilities are recomputed, and the idea is to make things tractable rather than just computing an entire mass of probabilities. You only compute the ones that are actually necessary, and it makes it easy to envision what events are dependent upon other events. So the Reverend Bayes, she seems like a really interesting character. I mean, he was busying himself with the probability. He was a minister of it. Anyway, there's Bayesian networks. Markov models, again, most people have heard of this, but it seems like it's a good idea to just, a little bit of review. The main benefit of this is that you don't have to remember prior states. So whatever state you're in right now, that's all you need to be concerned with, as long as the situation adheres to Markov properties, and they're observable, hidden, autonomous, and under the control of a decision maker. Create an optimal policy. Monte Carlo, don't know that much about this, but one of the traditional means of managing uncertainty, where suppose you're faced with some kind of problem, you can tell there's rules there, but it may be difficult to determine what the rules are. So you just run a lot of different circumstances, evaluations, and then eventually the machine learns by kind of like gambling. I guess when I read Monte Carlo, I think they meant like, well, it's kind of a gambling sort of a thing. But so it's statistically determined, I think. Anyway, I haven't really worked with that. I mean, so basic good old-fashioned AI decision making, the idea, and in human behavior in general, which makes perfect sense. The goal is always to maximize the chances of the best thing happening. So if you're doing that, you're probably pretty rational. If a machine's not doing that, then it might still be okay, but this is the main goal, I think, in life. Utility being good, we're just trying to get the best thing to happen. And there's a theory of preferences too, which might be good to bear in mind. That for example, if a person prefers A to B and B to C, they prefer A to C. And so this makes things a little bit more tractable when trying to compute. And there's simple decisions, and then there's more complicated ones. And there's theories for having multiple attributes. So if you're trying to, excuse me, if you're trying to select a car, you're going to look at a bunch of different things like miles per gallon, how many people can ride comfortably in it, what's the horsepower, things like that. So there's a theory to that, and good old-fashioned AI did a lot, and it seems like these techniques are still relevant. Satisficing is important by Herbert Simon. This is pretty old. So if you're faced with a situation that lacks information, you can't really optimize. You just want something that works well enough. Then you can use the theory of satisficing, which isn't concerned with an optimum. So we're not always necessarily optimizing agents. A lot of times we'll just pick the option that works well enough. I brought up information theory. It's information theory, as most people, if you looked into it, it's tough. It's got tough mathematics. And there's the famous ICSI theorem from, I think, like 20 years ago now, which tries to integrate algorithmic information theory and rewards, but is computationally intractable in the pure form. But one thing that in the Russell and Norvig AI book, they talk about this, and that's where I'm kind of basing this off of. They talk about the value of information. So if you're trying to make a decision, you want as much information as you can, but some information is more relevant than other information, and you might want to divert your plans if you know that knowing some piece of information is really going to help you. So that's kind of the main takeaway I get from that. Now I'm going to shift from some of these good old-fashioned AI methods, which I think are important, to some of the more contemporary methods I've been reading about and seeing. Use large language model as whatever is the basic movement now, as everybody knows. And I've got a couple examples coming up. And a lot of the contemporary literature that I see has to do with, the co-pilot, the AI helping the person, assisting the person, but not actually making the decisions. So I was kind of concentrating on autonomous AI decisions, for this event, because that's what's been puzzling me. But again, a lot of the literature is assisting humans. And another theme is the explainability, as just about everybody knows by now. It's usually pretty difficult to tell why the AI came up with the decision that it did. So there's the explainable XAI movement. 3 main principles: transparency, interpretability, and explainability. Good luck with that. Good old-fashioned AI could, there was somebody in there entering their rules, and you could see a clear chain of inference usually. So the problem is they didn't work. Good old-fashioned AI would top off and not work that well, when the combinatorial explosion took off too much. But so there's the challenge. Anyway, one of the LLM as X efforts underway that I read about was LLM as a judge. So if you've got one LLM and you're trying to test in the fine-tuning step how well it's doing, you use another LLM to judge the output. And you can have things like pick a winner. If the LLM you're trying to test comes up with 3 or 4 solutions, the LLM that you're using as a judge can pick the winner, or score the other LLM, decide which response is best. And they claim in this paper, which I give a reference to, that their approach is basically like human judging, which they use the phrase "human is a gold standard," which it sounds kind of dangerous to start saying that. But anyway, basically what they're saying is that if you click on this link to the paper, is that they can get the LLM to do about as well as the human, and in judging at the fine-tuning step. There's other things here. LLM is a critic, and in multimodal models, this paper I read there, they are saying basically that it will improve, what they've got will improve decision making. So it's been a while since I read that. Now, Ron's son, here we've got LLM as intuition, which is kind of like, I think, what Lance said previously. And that Ron's son, it was like 20 years ago, this was one of the first real neurosymbolic efforts with some bottom to it that I read about. And a lot of people have probably heard of him, but he's got kind of the bottom of his design has neural networks, and the top of it has symbolic rules. So he's got these 2 elements proceeding basically not exactly in parallel, but they both play off of each other. And this isn't not new. Again, it's pretty old. And Ron's son has published a paper here that in which he's envisioning how he could update his system's called Clarion, how he could update that so it could use the obvious power of large language models. And he likens the neural network part of his architecture to human intuition, to System 1, if you're familiar with that. And he basically, I want to read this because I think it's important what he wrote in there. He says, human intuition results from and relies on diverse, likely implicit, common sense knowledge about how the world works, including, for example, naive physics, folk psychology, folk sociology, and so on, which is what an extremely large amount of linguistic training data from diverse sources can provide. So basically, he's saying that the LLM, that's the intuition part of your judgment, which when I read that, I was yeah, he's right. I mean, you hear variations of this now, I know, but I like seeing it kind of a little more formalized in a paper. And of course, LLMs are often wrong, so is intuition. So anyway, and another contemporary method, which there's something important about this, which I wanted to bring up. A couple of things actually. And David Kelly, who Lance has met, and some of you have probably seen around, has been working on his AGI project for a while. And basically and he's also a co-organizer of the meetup, but he's never attended. But maybe, I can keep hoping he can come up, show up someday. But anyway, basically what he told me was he doesn't really care about, quote, logic and rational thinking. He wants the AI to be making decisions like people do. That's the intent. That's what he's working on. And so kind of a centerpiece of his design is the Plutchink emotional model with 8 emotional valences. And I'll bring up this. Here's the depiction. So basically, he scores the system, the goals around this variety of emotions. And he's also got biases built. Frankly, I don't completely understand this, but the important thing is that in his system, the system has the freedom to utilize, combinations of these various emotions, that he's explicitly using these to lead to a decision. He's got a pretty elaborate, I say he, but there's more than just him working on it, but he's got a pretty elaborate knowledge graph and some pretty interesting output that I've seen. So it's called ICOM. And again, it's basically the freedom of emotions that I think is the important thing here. And another team member, Curtin, who's associated with the Uplift Project, I got into a discussion with him about scalability, and it seems like, with present AI, which is very impressive, but you kind of wonder where it's going to top off, where it hasn't been exposed to, some circumstance in question. What's it going to do then? And it brings up the important issue of scalability, because it seems like we have this capacity to, okay, even if we haven't seen some specific circumstance, we can still kind of construct an outline of what's going to happen, and that scalability is an important aspect. And it brings up the and Curtin's Curtin, sorry, I didn't pronounce his name right, but anyway, in his he published a paper, and he's got this great depiction. Okay, suppose you've got, and I'm not sure if this is exactly the way he put it, but suppose you've got an AI system that hasn't been trained on a cat. You describe the cat to it, and can the AI system scale up with no prior knowledge at all to an image of a cat? Well, yeah, it should. But and I know this is bringing to mind diffusion theory and stuff like that. But the point is that suppose the AI is not challenged with a picture of a cat, which is pretty simple, but is challenged with trying to understand some kind of unique judgment that has a lot of uncertainty to it. and there's no training in advance. Can it construct some kind of silhouette of the situation, like the cat here? Can it do it or not? It's a puzzler. Well, I don't have the answer, but I mean, it's just something to keep in mind. And the last topic I want to bring up under contemporary methods, decision making under deep uncertainty, which is not exactly new, but I came across it. I forget who wrote a article on Medium. I can find the reference somewhere, but the author was saying, well, what does happen in complex judgments? Can we use decision making under deep uncertainty? Which I think this is 10 or 20. It's probably 20 years old in academic circles, and I hadn't known about this previously. But this is where I got that quote that I read previously, and it's there if you guys want to read it later. But the main emphasis here is on if you've got a situation with, a really complex situation with a lot of uncertainty, how do you get away without making the worst, without having the negative consequences come into play? So it's tools. It's not automation per se, really. It's more like a bunch of tools that you can utilize to try to work a complex problem. Like, I think they were using global warming as an example of a pretty serious problem. How do you avoid the worst things happening? But it doesn't have to be that dramatic of a problem. Excuse me. It could just be a more mundane problem. But suppose you just don't want suppose you've got a robot that's supposed to do something in manufacturing, but you don't want it to crush somebody. That's the worst outcome. That's probably a bad example, but anyway. So now we're going to move on. This is the discussion phase that at least that I had envisioned. And the kind of my own goal was to try to envision what some of these challenges are, and then maybe some kind of tools or design goals that we could use to fix some of the challenges, like good old-fashioned AI. It seems like would still be applicable to just general uncertainty, Bayesian networks, stuff like that. I don't know if the way it is right now, you just feed everything into the large language model. So you tell it how to do Bayesian networks, feed that in first. I don't know. Hallucinations, again, good understanding and reasoning. If the system doesn't really understand what it's doing, or it can't reason, the judgments are going to be pretty bad anyway. So it's still an important part. It's hard in AI to abstract some piece of mental processing, because everything is so connected. Like Jim Bromer told me once, there is no such thing as an independent concept. So the minute you start talking about something in isolation, you're automatically talking about everything else. So scalability, negative outcomes, like we could maybe use some methods from what I've had, decision making under deep uncertainty is what I was looking for. Intuition, LLM is intuition. And then this has been talked about already, freedom of action and volitional freedom. So if you're telling the AI what to do, if you're sitting there programming in exactly what to think, I don't see how it can actually make a true judgment. Now, that doesn't mean we should let it get away with any judgment. So what it does is really important. I don't mean to say that we should just let it do whatever it wants to. But it can think of the worst things, though. It can cogitate over what the worst thing would be, and say, well, I'm not going to do that. So anyway, that concludes my presentation. Does anyone have any comments at this point? Is anybody still there? I think I'll stop. Or should I keep sharing this? Any comments?
I have a quick comment.
Okay.
Thank you for putting the presentation together.
Oh, you're
Very
welcome. I
rich of information and researches. Thanks.
Thanks.
So I share your interest in, like, everything ties to everything, and the more training data it's got, the more chance it can get things really right or really wrong. And if you're looking for truth, you have to start coming up with criteria by which statements can be tested. And the AI has to get really good at testing it. And like in academia right now, LLMs make it 10 times easier to write research papers, but it does not make it 10 times easier to peer review research papers. And they already had a validity crisis with a lot of stuff that needed better peer review and wasn't getting it. And so this is potentially gasoline on the fire for that. So what academia could really use is, peer review buddy or truth tester copilot, or something that maybe it tries a grab bag of techniques of validating or invalidating any general statement or argument or thesis, and then circles that back into, here's a confidence factor that comes along with any assertion it makes, rather than just, I'm really smart, it must be true.
There's
Yeah.
a really good framework I found recently, a testing framework for LLMs called Prompt Foo, and has basically put in a bunch of prompts and test cases. Each test case has various assertions, and assertions could be, does the output contain specific words, regex, but also you could test it via other LLM, like let's call it LLM rubric, where you can say, is the output funny? Is it truthful according to this document, or how, yeah, according to does it abide by these facts? And so on. So in that sense, I think we do have a way to guide LLMs, and they have been, if you look at like GPT-3 versus 4, or even 3.5, the number of hallucinations has gone down drastically. I mean, for me, it rarely hallucinates. So I don't know. Like I think that's going to continue, and I don't see the need to go back to say these older methods to enforce factualness and reasoning. And reasoning is just going to get better and better with that, because they're going to train it into it.
I was
It
talking
seems
to
like
anyone who was talking
Go
about
ahead.
AI for coding, and he said, for senior programmers, it's no big deal because we spend most of our time reading other people's code, correcting it anyway. So AI is just an artificial junior coder for us. But for junior coders, it's a nightmare because it increases what they're expected to put out, and yet they don't necessarily have the skills to efficiently find the bugs. And if you don't spend a lot of time writing your own code and creating your own bugs, you don't get very good at learning to find and edit out bugs. And so that's another kind of truth, right? Or accuracy. It might not be hallucination, but it still could be an error.
Yeah, I mean, it's only certain percentage correct. And if you, in my work, some people are creating programs, and they're not even programmers, and they're trying to use the GPT to do it. But even if it's 90% correct, you still have to work on that 10%. And if you don't know how to fix it, you're screwed.
Yeah.
I think there's a fundamental flaw in the way that we think about artificial intelligence,
Oh,
because it comes from this conversation as well. I see at least two scenarios in which we want to use the artificial intelligence. One is like in the testing, we want to have a quote unquote predictable outcome because we have a test base, and then we would like to see this output. In that case, it's not much. I don't see it more like a reasoning per se, or having a artificial intelligence, because you don't want to give freedom to explore a space of probability solutions. I mean, problems. The second one is that we want to use artificial intelligence like an oracle. Oh, I have incompleted data, and then I want the artificial intelligence to give me the right information. How can, right? obviously there will be a sort of randomization of a guessing that even a human would do. So by definition, on giving all the informations make the artificial intelligence not an oracle. And then the first example I gave, if you want this to be an oracle, then you need to give all the information you have, and then you can expect the outcome and then test it. Otherwise, it's a contradiction in terms, I think.
Yeah. I mean, rationality is kind of interesting, though. Like, even though these LMs are trained on just next word prediction, they can actually spit out rational statements, and that actually helps them answer the questions.
Yeah.
Like you mean feedback? It's just some kind of a
Well,
feedback
there is
loop?
what is called chain of thought prompting.
Oh yeah, the chain of thought. Yeah.
Well, in this case specifically, I agree with you. They came up with a rational or a plausible outcome, but it is nothing like intelligence in that case, because we gave a lot of examples of statistical correlation between words, and then what the AI spits out is another set of words that statistically make sense for our brain. So essentially, they are digging out correlations from what we already provided, and then we think, oh, that's intelligent because this is a real poem or a real piece of poetry, etc. But it's actually because statistically came up with something that makes sense to us. There's a missing part in all this artificial intelligence thing, that is the conceptualization of exactly concepts, exactly one of the slides that I saw before. So one thing would be to narrate and learn. There's probabilities, there's connections. Another thing is to model in the artificial intelligence, coming up with a model of what the examples are giving. So I'll give you an example. So if you go into the law courts, like there are many judges applying a principle of freedom of speech or freedom of whatever that is, right? So then if you feed the artificial intelligence with all the cases in the past history, well, billion years or whatever, the statistical probability or connections between words used to describe a concept of freedom will make like the artificial intelligence understands the freedom. Another thing is that the artificial intelligence comes up with the concept of freedom for a person, and then it can apply it when missing information are placed, are like in the case to solve. That's, I don't know if I explain myself correctly.
It seems like that's pretty much the fundamental puzzle for me too. I mean, it seems like large models are kind of learning a concept, but you
Well, I
you
don't
wonder
know.
when it would top off, you know. And
I mean, I don't know what the difference between that and humans is like, because as it's learning, um, it it learns very low level representation, and then it generalizes more and more. The more words you give it, it generalizes to higher and higher levels of representation, until it has very high level of representation, like love.
I don't think
But it's correlation more than causation. It's association, statistical probability that this
yeah.
fits with that.
Sure, but
I,
what do
I had a
humans do?
I had a professor who said, we learn 3 levels. First, we learn to recognize something. Oh, yeah, I've seen that before. Then we learn to translate it. Oh, this is kind of like that. And then we learn to assimilate it, and we can build other concepts on top of it, and we can incorporate it into our general set of tools and concepts, as Luke was saying. And that's college freshmen. So if an AI is trying to do that, first it learns to recognize things. Yeah, that's in my database. Then it learns to translate it. Well, this often is similar to this, and so I can use them interchangeably, or I can substitute things that go with this for things that go with that. But then the assimilation is where, in theory, understanding arrives. And of course, that gets messy and amorphous. But it's going to be a real big question whether any subset of AI understands stuff and if it even needs to, and if understanding would be inefficient or if it would be efficient. Like if
Exactly.
you can generalize from concepts, then you've got a tool you can apply a lot of different ways. That's why humans do it, because it's more efficient use of brain power. But the way we're going about AI right now, it tends to be quite brute force. And so it might require even more processing power to have concepts than if we just do these, heuristic association cheats in AI.
Yeah, I like that number, the third one. It seems like that's the main challenge, the thing that's kind of worried me or been on my mind, I guess. I mean, you add in can the AI recombine its concepts and then also handle uncertainty that in a way that it may not have seen before. And
Yeah.
also incorporate some what I've been, intuition. Like that famous Supreme Court judge who was trying to rule on what counts as
Obscenity.
pornography. He
Yeah.
just said, "Well, I know it when I see it."
Yeah.
How do you get that? Okay, so suppose there's some new novel case at hand. How do you employ that same kind of "I know it when I see it" intuition? Lance, you got a look on your face like.
Well, I'm just thinking about um, just the concept. Yeah, I mean, AI is not as good at concept learning than humans are, but it can learn concepts. It can
Yeah.
take just from few shot learning. Give it an example. You describe a tool that doesn't exist based on its parts, and it will be able to tell you likely what things that tool could do
Hmm.
very quickly.
Yeah.
So, I don't know.
Yeah, that's I agree with you. In fact, I think that the problem we have right now is a resource limitation, in the sense that in order to grasp a concept in the multifaceted way that a human does, we would need much more data and the computational capacity to have a full model, because we describe, for example, killing someone. I have this idea that I get into a second. Involves a lot of things, right, to this concept. So you have a lot of computational capacity and processing to describe all the other concepts around that. Even a simpler thing like a tool you mentioned, we explore a tool in the reality, vision, audio, experience, what you can do with that. So it's very hard to do this one computation. And then a shortcut is literature, a lot of info in this way, and then hopefully if you model the AI to develop a concept instead of just statistical correlations, then you might get something out of that. And then at that point, if you have a concept, then you can apply judgment like a human would do, in the sense of, oh, okay, I see this case in the court saying, oh, this person killed this other one, or this person was self-defending and then killed this other person. And then maybe at some point, the AI, if it learns the concept, could say, you know what, killing another example of your species is a no-go, period. I don't need further examples. So in that case, it would be like a human saying, I don't know all the details, etc., but this is a full stop. So I can make a decision because I know the concept of preserving the life of another species, right?
So you mean it's learning, it's not being trained specifically. So nobody said don't kill somebody, but it just learned, I think, is what.
Yeah, it's a shortcut. Like in the slides you presented before with Markov chains and the other stochastical methods, etc. We did the same thing in the past where we had less computational power. So we extracted some analytical data because we were good with algorithms to compute those to make the situation more contained. Okay, and then we work with those. Now we have this extra power to have loose correlations and probability, and having neural networks doing these informal statistical correlations. And then we do that because we don't have the power yet to add other dimensions like audio, video, concept again, and emotions if you want as well. and so on, right? So those will come later when we will have more computational power, I believe. So yeah, this is my belief. Of course, I don't have data to.
Any other comments? What
I
about,
think,
okay,
I was just
go
going to say,
ahead.
I think one thing being overlooked in all these discussions is fundamental principles from philosophy. Like the language we use is imperfect and ambiguous to the point of being not just deceptive but nonsensical. And we've become so conditioned to this normal state of affairs that, and due to various different propaganda we consume, that humans have been taught that speaking clearly is the wrong thing to do. This is driven into our heads over and over and over in the media, by the experts, on social media, in schools. So I think if we don't acknowledge that the training set is it's almost like we've designed it to be deliberately misleading and confusing. And then on top of it, when judging, when humans are judging whether an AI has got it right or not, they're unable to consider whether we ourselves have it right in the first place. Like we are strongly biased to forming incorrect beliefs. Like it's a cultural, our culture insists on it to a substantial degree. So I think if we really want to fix all these things, we have to overcome ourselves as part of the entire undertaking.
Yeah. Are you the Trevor? You're the Trevor that goes to Victor's philosophy club, right?
Yeah.
Yeah. Okay. Yeah. I know. I'm
the guy that rants and raves all the time.
I want to do an event on nihilism because actually, what you were just saying that people are talking, but it's half of what they're saying is a bunch of bullshit. So why train on that? Why use that for your training data? I think that's your point. I mean,
there's nothing else to train on.
right.
That's all we have.
Yeah.
We don't have anything that isn't flawed. Like even in science, science is flawed too.
Yeah.
It sits on top of culture.
Yeah, but still, people like it anyway. What are you going to do if, I don't know. I think a lot of what comes out in AI is pretty rational. Especially, the problem solving is pretty good. But
yeah, I know, but
I think there's a big problem in copying the way people think, though. I've always wondered about that.
I disagree on this term. Sorry, not with you, Mike, in part of what Trevor said, because it is I think it's a feature that makes us unique and so thriving in this earth, that we are able to blur the edges and then cover a lot of possibilities, even though they are impossible or wrong, quote unquote. So give an example, very quick example, because if we would reason perfectly, there would be no variability and no discoveries, because everything would be optimal and then going to the point. Having instead a network, a neural network that is able to explore and then have a more broader approach that is imperfect, but allow us to explore other possibilities, will allow us to make errors, yes, sure, but also reach places that we wouldn't reach otherwise. So before I read a comment saying about the minimal the local optimal and the gradient descent and all the stuff. Yeah, but if you have a function that does like this, you will never find other peaks because you go to the optimal and then you are done. So we are lucky that our brain instead is not that optimal, and then we actually have biases, not bias, but we can explore probabilities, wrong or bad or whatever. Then wrong or bad depends on your function to optimize your goal. But so I think for all the bad things that happens, I think we are lucky to be in this way, and we would like the artificial intelligence to be in that way because it can explore more that we can do and come back with options.
Yeah, but as a counterpoint, I would say you're not even disagreeing with me. And this is a prime example of how complicated these things are. Plus you made predictions of the future under certain circumstances. This is hallucination, but we treat it as fact because it's culturally normalized, so on and so forth. Thinking too clearly is pedantic, and thou shalt not be pedantic. These are the problems.
Well, I don't know if we want to go full nihilist.
But it's not though. Again,
There's some
we
of
are.
it is. I mean, it's kind of like everything in philosophy is. You look at the poles, but then eventually you moderate.
So the whole trap with nihilism is it's easier to cast doubt than it is to prove something completely, conclusively, persuasively. So a certain school of thought just makes a game of, yeah, but you haven't done your perfect proof yet, so I still win. And you can make progress on the way to perfection, never achieve perfection, and still create incredible value.
But none of this is contrary to what I'm saying.
Okay.
You're
We're not trying
misrepresenting
to
what I'm
contradict you.
saying.
We're just looking at the general activity.
Yeah.
Correct. But are you not implying that you're disagreeing with me, or that what you are saying is critiquing assertions that I have made?
I'm more talking about the amount of weight I put in it. I totally give you credit that it's hard to do this stuff and that it's unlikely it will ever be done well, and that we come freighted with our biases that are part of our biology and part of our culture and our wetware programming and all that good stuff. And yet we made progress in the last year. It is likely we'll make progress in the next year. And how much progress, how satisfying that progress, that's very subjective.
Yeah.
And I think the
There's a lot of
goal is
unknowns.
not necessarily to make it perfectly accurate, but to make it useful.
Right.
And so far, I mean, I use it. I talk to my coworker, and they don't use Google half as much as they used to, or I use it for program. I mean, I've been programming for a long time. I use it all the time, even though it's probably maybe 60% correct.
Mhm.
Yeah, it still gets
But
you
it's
pretty
great
close.
at explain. I copy paste errors into it, and it can clarify those much better, so I can fix the problems. It
Yeah.
has definitely increased my speed of coding.
I put together a makeshift website, basically not knowing any of the like I've never been that crazy about like JavaScript and
Yeah,
I don't know. I just was never that
learning
crazy
like
about web pages. So I mean,
new topics. I looked into integrated information theory. It taught me that pretty well.
Yeah, I think it is. Yeah, I suppose that going back before, I wouldn't think about. I personally usually don't use the words bias or right or truth, etc. Because this is what I was disagreeing with. I don't look at the AI as an oracle that needs to tell me the truth, absolute truth. There is no such a thing, and then we cannot even the whatever science we have right now. There's no way that you can know whether it is or not. I think it's pointless to have that. I think like what you are saying, Lance, it would be very useful to help us. Would be very useful, like having a sounding board or exactly what you're doing. I look at that even tomorrow in the general artificial intelligence, like another human being that will help me more because they are better. The machines are better in tracking large amount of data, sifting it through. It's not like our brain that is less systematic in that.
And like a human, you only trust other people so far.
Yeah, exactly. Exactly.
And it's it can also be very entertaining.
Yeah,
Like
yeah, totally. I'm with you.
well, how many people think you could just keep training an LLM, you know, kind of onto infinity, and then it could make, you know, these kind of tricky judgments?
It's you're going to need to change the way you train it. It can't just be give it more data. You're going to have to eventually give it weighting and values, and your chances of having alignment probably aren't very good if you just train it on all the best and worst of humanity with all the bulk of data.
Oh, I have one point on this, saying kind of following what Chris was saying. One thing that I don't hear often is that the not the problem, but I would say the fact that the amount of information we can hold in here and an artificial intelligence can hold in their network or whatever mechanism is limited. So what you said a second ago, Mike, saying, train it infinity. Yeah, I can train it for the rest of you know, the universe, but the amount of information it can store is this one. So then something else goes in, something needs to goes out. There's no such a thing unless you develop a quantum artificial intelligence, maybe, in which you can stuff all the information you have. There's no such a way that you can reach that unlimited knowledge. You know.
One issue I've found with it also is that it doesn't know very well what it doesn't know. So, like humans, you know, I could say I'm not, you know, very good at quantum physics, and then I can go look it up and learn more about it. If LLMs knew what they were good at, more so, I know they have a cutoff date, and they know that, but right now they basically state the answer, and there's no true confidence. Like, it doesn't really give a very good
Yeah.
confidence. I don't
Yeah.
know what, and if it had the ability to kind of know what it's not confident about and try to learn it better to be more confident about it, that would be helpful.
Yeah, I think this goes back to what I said before. Using at this level, the AI uses mostly statistical correlation without developing concepts. Because what you are saying, I think it comes from the concepts. Because you know, okay, this area, you see, this area, you said quantum, etc. I don't know much about. You don't reason, oh, this is all the data I have. This is my universe. And there's the correlations between them. So I know everything. And then I don't need to improve. Okay.
Hey, Hugo, you've been sitting there pretty patiently. You have anything to interject?
Oh, yeah. So I just had a little bit of technical issue getting started with you guys. So I came in a little bit late into the conversation, but I think what you guys are saying is really interesting. It's one thing I could just tell you guys is that unfortunately, if LLMs were solely about informational, you know, helping you understand things or converse or that sort of thing, you know, no problem. But I'm seeing people look into LLMs for driving your car or
Yeah.
mission critical. And I'm going, guys, please no, don't do this. But there's major efforts where, you know, like when it does work, it works really well. But when it hallucinates while controlling a car, it's really, really bad.
Yeah, that's see, but that, yeah, that's when we need to clarify what the true judgment is, and if you know.
We really need to get better quality judgments and reasoning. I really think that's what I like about the RAG or advanced RAG, you know, where you're doing more knowledge graphs and all that sort of thing and causal models. But I do agree that there is no, you know, at the end of the day, I mean, we can have a colloquial causality, but you don't have real causality. It doesn't exist, right? You can almost mathematically prove the causality, even with an infinite amount of evidence. I was working on a proof where with infinite evidence, you still don't have enough to prove that there's a cause.
That's an undecidable problem. Yeah, exactly.
It's kind of an approximations game.
Exactly.
Get closer to what causality is, get closer to what.
Yeah, it's kind of, there's always a certain, you know, probabilistic. And as long as we're always, I think that goes back to what I think Trevor was saying, right? Which is, you know, it's what I'm finding as we build more, as I personally am building more advanced forms of AI, trying to even when people see that it's doing something remarkably different than like large language models or machine learning, even when they see it, to try to explain it requires a different way of thinking as a human, right? So we as humans, we have Korsivsky talked a lot about this, right? So we mix levels of abstraction. We don't use language correct. We're limited by our language. We, at a very subconscious level, identify this is that. We think everything is kind of additive, right? Where if you have I know two of you, and therefore, since I know you two, I can take an elementalistic approach and say now I know what the combination of you two would come up with. The world is not additive, right? Additive. 1 + 1 does not equal 2 in the real world, but all these things are kind of at the heart of what I'm finding real AI is about. And until you, as a person, can kind of move beyond these, and these are kind of habits that we've learned very young, right? If you may not be aware that you're identifying mixing levels of abstraction, doing all these things, but the only awareness you would have would be that you always feel stressed and shitty because you're mixing in your mind these, oh my God, the Democrats or the Republicans or Trump or Biden or whatever. These, you're mixing that with physiological things and your body's getting very stressed out, right? So that would be an indication that you are mixing levels of abstraction, and maybe that's but what I'm finding is it's impossible for an AI that incorporates kind of the next level of being or thinking with people that haven't quite reached that yet. Anybody can do it. It's not like there's one person's better than another. It's just, do you have all these habits ingrained for whatever reason, so yeah. Interesting time.
Do you think we could teach the AI to be?
Oh, that's what I'm doing. And I spent like a lot of time on myself studying. Honestly, I had to read his Science and Sanity and Manhood of Humanity probably 10 times to fully begin to absorb it. But it's not just about reading it. You slowly become aware of, he said it in a very simple way. He said the first job for all humans should be to learn to control your secretions, right? So like, so it means that, one of the things is like, if you have a symbol and, it's happy or sad for you, whatever it is, that symbol, when you think of it, will make you have all the physiological, responses, hormonal responses, as it would in the real world, right? So that's why that causes, so if the first thing he said was first be aware how these symbols are affecting you, and then try to start to kind of get control of your own, he called it psychophysiology.
I have a question on this, right? This kind of came from what I was saying before. What's the point for me? What's the point of trying to have an artificial intelligence that is human-like when you don't provide that agent the same variety set of inputs that we have right now, that we have?
My objective is to, I'm more of an engineer, right? So I was 30 years in engineering. I like to build things that work extremely well. Like most TVs have my security chips in them. I've done billions of them, right? If I would have screwed up when they produce these billions of chips, it would have been a disaster. So the reason I'm into this kind of AGI, I don't know what we want to call it, because AGI is so ill-defined, but I think that humanity has a lot of need for real AI that could, handle your robotics at home and not kill you and do things well. It can drive your car. That can, all these things, require something a little bit more than a large language model. And by the way, LLM technology, I love it. It's all part of it, right? There's nothing wrong with it. We just need a little bit more.
Yeah, I agree with you. I was just connected with what Lance said before, because at this point, it seems that we're restricting a little bit from the dream of having another artificial human around to something more useful that Lance was saying, that is a little bit more focused, right?
Yeah, I think that's crucial here, because I know that and I think it goes back to what I started with, which is until we kind of work out our own, what Trevor was saying really well, until we kind of work out how we think and how we use language, how we go from what Korsivsky called the childhood of humanity, which is where we are, where we have these world wars and all this disaster that's going on, to a more mature way of being, where we and like you said, though, I mean, the argument that we continue to advance is fantastic. But one of the consequences I see is that a lot of the AI people, when I talk to them, I mean, a lot of my friends, I say, why do you want, I asked the same question you asked. I said, why do you want like a human-like intelligence? Isn't that going to be, if it has, what if it is human-like, but it's extremely powerful and it's emotional and it gets upset?
Mhm.
You know, what if it's like a baby, but it's a baby with 500 IQ with nuclear bombs, right?
Yeah.
It's like,
We agree on that.
but what they say then is, well, then I would be, even if they blow humanity up, I will go down in the history of the universe as the person that created it. And I'm going,
Really say that?
I'm going,
Well, it's, you know, at least you got somewhere.
yeah. But maybe that's where you're at, Mike. But I think we really want to focus on making useful AI.
Yeah.
You know, there's no need to make it emotional or upset. And honestly, maybe
Exactly.
it's a good thing. I think it's unlikely that until we advance to whatever this next level is, that we don't make all these errors in thinking and language, because it requires a new language actually, you know, to get past this. And you know, we're still kind of Aristotelian, where identification, this is that, is kind of very core of what we do. But until we get to the next level, I'm not entirely sure that we can come up with an AGI. So maybe that's a good self-limiting thing.
That's
We have to kind of ourselves, yeah.
Yeah, that's a different, I think, a different topic. But yeah, okay.
Yeah.
I wanted to touch on one thing you started with, just to close the loop up, I would say, because I think some level of conceptualization and bias needs to be put in place. And I give you an example, or at least a question to think about cars. I remember one of the common things that came up when this autonomous driving, was picking up with Tesla and all that stuff, saying, okay, how would you do if you go down the road and then you need to brake or steer, and then in one case you kill 3 people, another case you kill one?
Oh,
That's
the
a kind of
trolley
thing that
problem sounds like.
yeah, right.
Yeah.
This kind of thing. So this is an example for me in which you want to have those useful AIs with some bias in place, because obviously you need to reflect what we think the law or what the common norms would do, even though there is no perfect solution or something like that, right? So I think it kind of close the loop in this example. Useful, but we
You
need.
can't get away. Yeah, you can't get
Yeah.
away from bias. Yeah.
Yeah. I don't think you can. Yeah.
And by the way, that takes us to like inductive bias, which is the inductive bias is kind of like, what is it at the highest level? How does it learn? The meta learning. What is it driving the learning process, right? And maybe you could say something to, the number of years of human life saved. So that maybe would cover like older people versus young people,
Yeah.
two
Yeah.
80-year-olds
Totally.
versus two young people. I don't know.
Totally. Or it could be a random choice, because I think in a situation like that, if it happens to a human, right, you go to a judge and then the judge will say, oh, there was a malfunction. Okay, fine. Do I condemn you because you decide to hit 3 people or one, or you didn't have any choice, so it really doesn't matter. I know, I find it
I think
interesting.
that's interesting, Trevor. I've decided to be autistic. I mean, hey, autistic people do some of the best things, man.
A good point. Okay, well, I would love to stay longer, but I have to go. But yeah,
Yeah, okay.
it's
See you
been
next.
great,
Hopefully
guys.
we'll have some more meetups pretty soon, I hope.
Great
Thank you
conversation.
for organizing it.
Uh-huh.
Oh, you're welcome.
Yeah.
Thanks.
Yeah.
Looks like somebody else left.
I know.
Well, we're just about out of time anyway. Do you want to call it a day? Oh, Hugo left.
Yeah.
Okay.
We could probably call it.
Yeah, I mean, a lot of things to think about. I'm still kind of lost, but a lot of, Sunday's a good time for some philosophy.
Yeah.
But yeah, I mean, I guess I'm thinking, when I started the group, I wanted to do understanding, reasoning, and judging. And so this pretty much wraps it up. I think at least for my own purposes, pushed judgment as far as can go for the moment anyway. So that kind of leaves reasoning. I mean, reasoning pretty much includes learning too. A role of learning under reasoning, induction.
Yeah, but it's a higher level learning, higher level abstraction.
But
I have
anyway,
another theory.
hello. Oh,
I have another theory.
oh, let's hear it then.
You know the title of the Google paper, "Attention is all you need."
Yeah, yeah. I forgot to mention that too, because I don't quite buy into that.
I think there's something to it because if you notice the conversation, when I tabled my proposition, and if you observe the reaction of all the agents in this conversation, they were all trying to get away from it. They were trying to imply that there's nothing to be considered here, that we're doing just fine. Humans are not perfect, but nothing's perfect, so on and so forth. We live in this story world, and you can't get humans to stop doing this. It happens every time. You can't get, there are certain ideas that humans cannot focus on. Their mind will take them away intuitively from certain ideas. Anything regarding consciousness, reality, cultural norms, methodologies for thinking, the notion of truth, anywhere in this conceptual area, you can easily predict. You can say, I'm going to prompt these humans with this, and it's very easy to predict what their behaviors will be. It'll come from a very small set.
Is it? Well, I mean, what if it's a novel type of situation that the people haven't seen before, and
I don't. What would be such a situation? If it's truly novel, then perhaps you would get novel behavior. I doubt it though, because humans, reality is indirect realism, but we experience it as direct realism, right? So whenever you introduce an idea to someone, they're not dealing with the idea, they're dealing with an interpretation of it. And if you remind people that they're dealing with an interpretation of the idea, not the idea itself, even if you're in a philosophy meetup, people are going to say they're going to disallow that perspective. Even in a meetup where they are presenting the fact that we experience reality indirectly, right? So the very same person that is asserting that proposition, if you then use it on some of their claims, they will say it's not fair. And you think, this can't be possible, you might say. But I swear to God, I've seen it over and over and over. The problem is humans. The problem is culture. The problem is language. Ego, emotions, all these things. Consciousness. I mean, it all comes down to consciousness space at the end of the day. Right? Because we think, doesn't our culture teach us that that we're in reality and that we are perceiving reality? But we well know that from science that reality is first generated by the mind and then it's perceived. Right? This is known, but we speak as if it's the opposite of that. Right? So if we refuse to attack the root of the problem, I don't know if we're certainly going to make forward progress. I don't doubt that at all. We're always going to get better approximations, but
you'd like to fix the human race, though, I think.
Yeah.
That might be beyond the scope of the the event, but I mean, I
don't think it is, because if you're expecting, if you're designing AGI to model humans, you're going to end up with an extremely flawed machine at the end of the day.
Well, hopefully it would get to super intelligence, where, to me, when I think of super intelligence, it doesn't have the same kind of problems we do, like fallacies, for example. So a super intelligent wouldn't fall for a fallacy, or an obvious falsehood. And human beings, we fall for everybody that votes for Donald Trump falls for falsehoods and fallacies. So
Smart people fall for fallacies all the time.
yeah,
If it's
that
taught,
too.
if it's taught in their core curriculum, take scientists, for example. Scientists, these are our brightest minds on the planet. But if you listen to a scientist, they will tell you that an absence of evidence is proof of absence with completely no irony whatsoever. They won't say it in those words, but they will say it using different language, or they will say there is no evidence. This is pseudoscientific thinking, yet scientists regularly engage in it. That's a fact.
Well, well, I guess we're just about out of time. This is I mean, it's a pretty big challenge we're up against.
Yep.
Anybody have any last comments? I'd like to. I mean, thanks to everybody that's still here, and thanks to everybody that's left and is watching it on video.
Just that I am interested in rationality. I wonder if we should do a meetup on that next.
Well, you want to work on reasoning? Reasoning? I guess. I mean, reasoning is based. Well,
Reasoning, rationale, same difference to me.
is it? Yeah, yeah. Well, I mean, reasoning kind of. Well, I was thinking you kind of start off with deduction and induction, and I mean, it's supposed to be rational. So, how about
We could talk about it. Why?
reasoning / rational for an event? But
Sure.
but I mean, I want to do something on integrating cognitive architectures and large models too. I want to do that, and I want to do yeah, the kind of thing that we were talking about. And it seems like these Sunday's a good time for these kind of explorations. So hopefully we can get this going again. It seems like we lost momentum for a while, but
Yeah.
but this this is pretty good. I'm coming away with the that fuzzy feeling like it forced me to think a little bit. You know, I can Trevor, I might not completely understand all of what you said, but I understood some of it. All right. Thanks, Trevor.
Cool.
And all right, so that's it, guys. See you next time if there is one. I hope.
Yeah.
Adios.